I'll keep an eye on. All right, y'all. Well, here we go. So, it says express each number in scientific notation. So what we've got is a really, really small number here, right? And so this is a really, really small number. That means that our exponent is going to end up being a negative one, which we'll talk about. Yes, what's up, Isaac? Yeah, go for it, man. So here's what we're going to do. We've got to move our decimal, okay? So here's my decimal. Move it 1 place, 2 place, 3, 4, 5, 6. Can anybody tell me why I'm stopping right there? Why am I stopping there? Josh. Good. I need a number in the ones place. So can we all agree that my number is going to be 5.6? And what am I going to multiply that 5.6 by? Can anybody tell me that? Josh, you're on a roll. Let's do it. 10. Times 10. Is everybody okay with that step so far? Now here's the hardest part of this entire process. I've got to figure out what my exponent's going to be. That exponent is based off how many times we move the decimal. So let's count it again. 1, 2, 3, 4, 5, 6. So I'm going to put a 6 for my exponent. Are we okay with that? Now is it going to be a positive or a negative 6? Zion, why?
We're moving the decimal. We move the decimal back.
Good. If the zeros are to the left, just like on a number line, do we agree that negative numbers are over on this side of 0 and positive numbers are over here? If the zeros are to the left, it's going to be negative. If the zeros are to the right, it's going to be positive. Does that make sense? If it's a really small number, it's going to be negative. If it's a really big number, it's going to be positive. We'll practice some more examples. Okay? Questions on number 1. Number 2 here. Do I have a decimal given to me? So where do I have to assume that that decimal is going to be, Nathan? What?
Number 2?
Yeah.
It'll be like right after the 9.
Where is the decimal at this current point in that number?
Oh, it's at the very end.
To the very end, right? So here's my decimal. And I'm going to move this and slot it in between what 2 numbers? Rosie?
2, 5.
Not the 2, 5, because then I've got 1, 2, 3, 4 numbers to the left of it. You want to try again?
So then between the 9 and...
Yeah, between the 9 and the 0. Good. So it's going to be 1, 2, 3, 4, 5, 6, 7. Are we okay with that? Okay, but now here's the hard part, y'all. Here's what we have to remember. Every non-zero number has to be written. So it's going to be 9.0825. Every non-zero number, I want it to be written. And what am I going to multiply that by, Ruger? Times 10. And then what's my exponent going to be, Kendall? 1, 2, 3, 4, 5, 6, 7. Is it going to be a positive or a negative 7? Down? Positive. Do you understand that? All right, here's what I want you to do. 745,000. I want you to write that down on your paper. 745, comma, 000. 745, comma, 000. And I want you to try to solve that one on your own. 745, comma, 000. I want you to try to write that in scientific notation on your own. Isaac, do you have paper out or are you on the computer? Because I think it would help to be taking some notes right now. Kaden, what'd you get?
7.45
Times 10 to the what? All right, let's check him. Here's my decimal. 1, 2, 3, 4, 5. He stopped in the right spot, which is excellent. Now it's times 10 to the 5th. I agree. Do we agree with him?
Yes.
All right, let's do this next one right here. Here's my decimal. Notice that the zeros are to the left of my numbers, my non-zero digit. So that means that there's going to be a negative exponent. Can we all agree with that? All right, so I'm going to move it. Where am I going to move it to? Can anybody tell me where I'm going to, Anthony, where am I going to move it to?
Your decimal?
Yeah.
And you're gonna move it between the 3 and the 7 and the 7 on the left.
Excellent. Great job. Thank you, sir. 1, 2, 3, 4, 5, 6, 7, 8. So now I've got 3.77. We all okay with why I have a 3.77? Okay, that's going to be times 10 to the what exponent? And what did I forget to put on my exponent? What do I have to have and why? To have a negative, and I have to have a negative because it's a really small number, and the zeros are all to the left of it. Are we good there? All right, I want you to try number 5 on your own. Try number 5 on your own. That is, I could have done something wrong. Am I right? Do you agree? Josh, what's wrong?
Oh, never mind. I didn't know.
Read.
Is the 0 supposed to be there?
Right here, where I put the 1.0. I only put the 1.0 there, Reed, to show you that I only had one number to the left of it. 1.0 and 1 would be the exact same thing. So I would take it either way, but just to show the consistency with the decimal is why I put it there. Questions on that? All right, let's look at it from the opposite way now. Let's look at it when we're given scientific notation and we need to write it in standard form. Let me do this real quick. So let's do it when we're given scientific notation and we want to write it in standard form. All right, so I'm going to leave my number line up there. That's a big piece. And then we're going to work through these. I personally think this way is a little bit easier, but you might not. Okay, so here we're given our numbers. So we have 1.028, and we're multiplying that by 10 decimal spots. Or I'm sorry, 9 decimal spots. So here's how this is going to look. I'm going to write 1.028 right here. Is everybody okay with that? And am I going to move to the left or the right? And tell me, how do you know? Josh?
Right?
To the right, because positive goes to the right, negative goes to the left. Can we agree with that? But now here, watch this. 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do I have to fill in to all of those half U's or half circles? Nathan?
Zeros.
Zeros. So now I've got 0, 0, 0, 0, 0, 0, and technically this decimal is no longer there. Where is it at?
Oh, that's at the very end.
At the very, very end. Do we agree with that? Okay? Is everybody okay with how I did that one?
Yeah.
Okay, does that make sense? Okay? This is number 2 together. I've got a negative. Does everybody see my negative? So Mariah, which way am I going to go now?
To the left.
To the left. So here's what I'm going to do, ladies and gentlemen, and this is just me seeing the negative, understanding it. I'm going to write my 5.61, but I'm going to write it to the right over there because I know my zeros are going to be on the left. Okay? Ruger, how many times do I have to move that decimal over? 11, right? So don't forget this 1, okay? That's still a moving spot. We're not counting zeros, we're counting how many times we move it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here's my decimal now. I can erase it from over here. And what do I fill all these blanks with? Rosie? Zeros. Are we okay with that?
Yeah.
All right, hey, you try number 3 now. You try number 3. The number is 4.128. 4.128 times 10 to the 10th. 4.128 times 10 to the 10th. 4.128 times 10 to the 10th. Josh got a question, he's got the answer for me. The answer? What do you mean you had it? Did it just fall off your paper?
Oh, no, I didn't see, I thought you had, 4.120.
Gotcha. So let me ask you this, Josh, how many zeros did you have on your paper? How many did you have to add?
7?
7. Anthony, how many did you have to add? Well, so it's not 10 zeros, Anthony. That's how many decimal places we're moving. And so since my decimal started here, Anthony, 1, 2, 3 of my decimal movements are with these numbers right here. So I'm only adding 7 zeros. All right, let's try number 9. I've got a negative exponent, so my zero is going to be before or after the non-zero digits? Before, right? Because it's negative. So I'm going to go ahead and write my 2.9 over here. Does everybody understand why I'm writing my 2.9 over there? And how many times do I have to move the decimal now, Mariah? 8 times. So Anthony, look, that counts as one of my decimal moves around that number. So that's 1, 2, 3, 4, 5, 6, 7, 8. Now my decimal's up front here. Fill in the zeros. And that's my new answer. Are we okay there? All right, I would like everybody to try number 10 on their own, please. I'll read the number out loud for you. It is 6.542, 6.542 times 10 to the negative 12. 6.542 times 10 to the negative 12. It's what? Oh, perfect. What's up, Anthony? Do we understand how this works? All right, cool. What I want to do real quick, I just want to go over your homework assignment with you very briefly. Let me pull that up for you. All right, so these notes are in there in case you need to go back to them. Here's your assignment. Now, hear me out on this first part. For you face-to-face, here's what I want. I want you to solve this out on notebook paper and bring it to class tomorrow so we can grade it in class so I can give you instant feedback. Does that make sense? So that way I can say, hey, Josh, you did great. Hey, Kate, you did great. Rosie, let's talk about it, okay? So we're going to grade it like you guys would last year. Like, I'm going to have the key in my hand. I'm going to read them out loud. Are we okay with that? Online students, you guys are going to submit it just like you've been doing. Take a picture of your work and upload it to me so I can grade it myself, okay? Here's your assignment. Write each number in scientific notation. Write each number in standard notation. And there's a couple word problems at the very bottom of that. Read. Yeah, what's up?